Hi everybody, and welcome to today's lesson on volume of prisms. For this lesson, you're going to want to have your math notebook, a pencil or a pen, and your calculator. If you need to, go ahead and pause the video at this time, and you can hit resume as soon as you're ready. So just so we are all on the same page, let's think about what volume really is. So volume is defined as the amount of space a three-dimensional figure takes up. Think about it like this. How much space would it take to fill that particular three-dimensional figure? So the formula for calculating volume of three-dimensional figures is generally known as capital B times capital H. And basically what that means is capital B represents the area of the base of the figure. Reminder that bases are sometimes called faces. And capital H represents the distance between the congruent bases. Taking a look at a triangular prism here, you can see that there are two triangular faces. Okay, so here at the front there is a triangle, and then at the back there will be an additional triangle. So the area of that base is what capital B represents. Capital H is the distance between those two triangular sides of our figure. So some specific things to write down for your notes. The formula, V is equal to capital B times capital H. Let's write down that capital B is equal to the area of the base. Capital H represents the distance between the two congruent bases. Okay, so in this problem, the area of the base is a triangle. So the area of a triangle would be found by doing base times height divided by 2. Now in this case, notice that I used lowercase b and lowercase h. Let's just designate what those really represent. The lowercase b and the lowercase h represent the base of the triangular side. Lowercase h represents the height of the triangular side. Now, good thing to know is that the base and the height of the triangle are always going to be the two that form a right angle. Okay, so on our diagram here, the base is the bottom of our triangle and the height, and notice that those two always form a right angle. So that's how you make sure that you always get the correct dimensions. Let's take a look at a specific example. I would highly recommend that you sketch this figure. Pause the video right now, sketch this figure into your notebook, and do this example problem along with me. You can go ahead and resume as soon as you've completed the sketch. So I'm going to start by writing our formula. V equals base times height. And remember that the base is a triangular side, so base times height divided by 2 times the height, which is really the distance between the two triangular faces. In that case, in this example, that's this side right over here. So when I substitute in my values, this lowercase b and lowercase h are the two sides of the triangle that form a right angle. So that's going to be 16 times 12 divided by 2 times the distance in between, which is 10 centimeters. Okay, so 12 times 16 is 192 divided by 2. 192 divided by 2 equals 96, and 96 times 10 is 960. Now, volume is what we use to figure out the amount of space in a 3D object. That's important to know because there are three dimensions, and that means that our label needs to be to the third power. I always say 3 for the V, my friends. Make sure that you know that your label should always be cubed or to the third power. One quick thing here, ladies and gentlemen, you may have noticed that we did not use the dimension 20 centimeters at all in our calculation. We would need that dimension if we were trying to figure out the surface area of this figure, but we do not need it for volume. So please make sure that you do understand which values are which in your figure. So some students will just try to throw things in. All right, ladies and gentlemen, let's take a look at another example here. Okay, in this triangular prism, our figure looks just a little bit differently. And so again, I'm going to start with our formula. And I'm going to break that formula down a little bit. Capital B stands for, or represents the area of the triangular base. And the triangular base is found by doing base times height divided by 2. Times capital H, which is that distance in between triangles. So this time I am substituting in base, lowercase b and lowercase h. They're the two that come together and form the right angle within the triangular face. So that is 12 times 8. And capital H, the distance between our triangular sides, is 34. All right, doing my work in the parentheses first. 12 times 8 gives me 96. And 96 divided by 2 is equal to 48. 48 times capital H, the distance between triangles, is equal to 1,632 centimeters cubed. Don't forget your exponent of 3 on your label. Okay, ladies and gentlemen, this shape looks a little different because it is. It is not a triangular prism. This is a rectangular prism. I saved this one for last, you guys, because it's actually super easy, easiest one of the bunch. Okay, our formula is still going to be capital B times capital H. And if you haven't heard me say enough times, capital B represents the area of the base. Since the base is a rectangle, that really means we're going to be doing length times width to find that area. And we're going to take that times the distance between the two bases, or the height. Okay, so for this problem, that's going to be 10 times 3 for the area of our base. And the height of the figure, the distance between those faces, is 4. Okay, 10 times 3 is equal to 30. 30 times 4 is equal to 120. And again, inches cubed for the label. 3 for the V. All right, ladies and gentlemen, I think you have enough to get started. I wish you luck in your assignment today.